Okay, so here's IFI, our line following robot. We started off with an Arduino Uno circuit board and motor shield combo we bought those at Radio Shack. You could get them offline at Amazon or other websites, but we chose to get them at Radio Shack. They were 35 bucks, but the benefit of them is they're already all pre-soldered. There's no soldering of pins that you need to do as on other motor shields. Also, we got an engine here in a little engine gearbox kit because we wanted to make sure we could control the RPMs, and there was different RPMs you could set the gearbox up for. It didn't come assembled, we had to assemble it, but all the parts came together. And the final major piece is the sensors here. We got them from pololu.com. They came in a pack of 8 digital sensors. You can also get analog sensors. It's just you'll have to program them differently. And other minor parts, we got the wires and the tape also from Radio Shack and Walmart.
Alright, so I'm Daniel, and I'm going to discuss the soldering and installing of the computer program. So once we had all the components, the next step was to do the soldering on the board. With this pretty much pre-purchased setup, the soldering was minor. We soldered the wires onto the sensor here, and then we soldered the resistor onto the sensor as well. We had to be very careful when soldering because those connections are very small and they're close together. So we had to use small amounts of solder and work slowly. At first we soldered the board incorrectly, and so with the wires basically coming in from the bottom and going up. So in order to fix that, we unsoldered it and resoldered it the way you see now. And in doing that, we actually destroyed the board. So for future reference, it's really important to be exacting and take your time with the solder because it's really very difficult to undo. On the back side of the robot, you have the motors and their wire connections. It's not completely necessary to solder them, but with the other troubles that we've had with the robot, we didn't want a loose connection to be one of the issues. So we soldered it and never really had any issues with that. Moving on to installing the program. It's a simple program download. As far as the drivers, you have to manually install the drivers through Windows Device Manager. There's instructions on the Arduino website, but Windows will not automatically detect the drivers, so it's a manual install. Once you get into the Arduino environment, there are templates that you can use, preset lines of code to get the LEDs to blink, stuff like that, so you know that you have a working board. And to give you a little bit of an example of the C-type code that the Arduino uses.
Okay, I'm Eric, and I'm going to be talking about the coding of the actual robot. And in the Arduino program, we found a library of things with the motor and the sensor. And the motor code, we just messed around with that a bit, and we enabled it to go forward and turn left and right by altering the speed of the 2 wheels. And we also found code for the sensor, which required a lot more editing around. And the way we did it was we had 2 sensors here, one underneath here and here, and we detected it so that when the line was underneath, right in the middle, the robot would go straight, and when detecting one over to the left, the robot would know to turn left to stay onto the line, and when the right sensor detected it, we know that the robot needed to go straight. We did this by having the sensors detect from 0 to 9, 0 being the lightest part, the floor, and 9 being the tape. And the robot determined its position by a number from 0 to 1,000. A 0 meant that the robot was too far to the left and needed to turn right, and a 1,000 mean the robot was too far to the right and needed to turn left.
Hi, I'm Justin Branham, and I'm going to be talking about some of the troubleshooting issues. First off, we started using a 12-volt connection and we plug that in back here into the 12-volt battery supply. And that at first was a little too fast, and so we determined that we needed to slow down the amount that the wheels were turning using the code. And after we had some problems with that, we attempted to use a 9-volt power supply, but that proved difficult as well. So we switched back to the 12-volt and messed around with the code some more and determined some good coding options that would turn the wheels at a steady pace that we desired. And also, we determined that we needed to have the wheels turning at a different rate. Initially, we had the wheel that needed to slow down so that we could turn right or left. We had that wheel completely stopping. And when we wanted to smooth out the robot, we decided to have the wheel that needed to slow down to continue to turn slightly so that we didn't have a jerky reaction, but that we had a smooth turn as it was following the line. And finally, there were some minor issues that we needed to correct just with wiring and coding, but just with time and patience, we were able to determine the different pins that we needed to use, and also the different inputs that we needed to put into the code. And so basically that gives you a synopsis of our IFI-Bot Arduino project for a line following robot, and enjoy.